Y'all got any questions so far? Y'all got anything you want to talk through or anything?
I do. Okay, so when I'm right, so
Let,
I'm lived.
let me see your screen so I can see.
Okay. Let me know if you see it.
I see a yeah, I see it. Let me stop. Okay, so you got select. Okay, so that's good. That's good. That's good. Put your bracket at the end of line 10. I mean, on the other side of payment. But okay, you got from customers. Okay, 11 is right. This is right. Yeah, this right now. The next thing you need to join. Yep, get rid of that. You gonna yep. And
But okay, so but what am I joining on? Order
so,
ID?
huh?
What am I joining on? Order ID?
Yes.
Okay.
Yep. Yep. Just like that. And then you notice how, like, when you are doing the multiple joins, you just layer them right on top. Um, you do your, yeah, yeah. So,
All right, I'm scared.
where is, hold on, let me look at my code. So, on line 10, you got payments. That's not a column. So that's why, yep, invalid column name. Yep. So that's the problem with that one. But I like how on line one it said customer ID and that would have gave you an error on that because it would have said, okay, well, this is ambiguous. We pulling it from multiple tables. So tell us which table you want us to pull it on. And you put C. So you basically say, okay, I want the customer ID from the customer table. But other than that, so let me see. We want our first name, last name, email, address, phone, join date, payment method. Okay, okay. So you still working. But yeah, that's right though. Do anybody have any questions looking at her code?
I just didn't understand where to start, but seeing it kind of helped.
Okay, okay, okay. Good. The best way to know where to start is reverse engineer. Okay, what am I looking for? What am I looking for? And then where is it? And that's where you start at. Okay, start with like the business question first. What are y'all looking for? Now let me go and do my data investigation. Okay, those columns are in this table. So I need this table. Now let me see what else y'all need. Oh, excuse me, friend. Oh, okay. I just saw your chat. But yep, perfect. Now you notice how the way that your logic is, it pulls customers regardless on if they place the order or not. And that's the beauty of that left join on that customer table. Because we're left joining on this table. So give me all the data regardless on if y'all have a match or not. So yeah. That's good. Now you need to filter it down where the order date is between and where the order date is in the year of 2024. You need the order date too. I think the order date come from the orders table. Yeah, I'm gonna share my screen. Oh, let me get to the logical operators. Hold on. So, okay, here we go. So the use case was select all those columns from all those tables, which is what Bree did. Then I only want data where the order date is in the year of 2024. In order to get that year of 2024, we would need to use this logical operator, which is between. Select, we got all our select. From, we got all our tables. Where, we get into our conditions. Where, order date. And then you list out your logic. Make sure your values and your logical operator match the values in your data. Make sure that like whatever's in your table, that's what your code is reflecting.
Can I see the code one more time?
Mm-hmm.
My,
Or you want to show yours?
oh no, I was asking. I didn't know she was talking about.
You talking about the code of IKEA? You talking about like
The yeah,
okay,
like
okay, okay,
this.
okay, okay. Make sure you document what you're doing at the top too. Can you go back up so I can see your documentation? Make sure I got mine. Okay. And when I originally did it, like it went all the way over, and I'm like, I can't even read this. So I just pulled it down like that. Yeah, I got any other questions on the logic? Okay. So, okay. Now that you got your logic, now let's build out our CTE. So we're gonna build our CTE around our logic. So we got with whatever our CTE name is. Let's say 24. I mean, not 2024, y'all. I'm tripping. 2024 orders or something, because that's like what the logic capturing. So with our CTE name as, open up your parentheses around your logic and then close it. Then you come down and you select star or select data from that CTE. Remember, remember how I was telling you how to write your code in pieces? Like, okay, let's see, let's make sure that this works. Now we're gonna go and we're gonna make sure that works. Now we're gonna go and we're gonna make sure this works. This is what we're doing now. We got our logic. Now we're gonna go and stretch it out a little bit and build our CTE on top of it. But use what you already have to do this. Okay. All right. I'll be able to make sure I'll be running code with y'all. Any questions on that? Or anything that you want to talk through? Oh, and another thing with a CTE, if I'm writing my CTE, I can't just execute this with and all this logic. It ain't gonna work like that. I gotta execute the full block of syntax. So it has to be with all of my logic, close the parentheses, and a select statement. If you only try to do that, it's not a full CTE. So it's gonna throw you an error. All right. So were y'all able to retrieve data from the CTE? Select start from your actual CTE as opposed to like the table, like this. Why you so quiet? Shit.
Okay, so I think for me, what I'm trying to figure out is after I've joined my tables and I've selected all the orders for 2024.
Which is your CTE
So,
name?
mhm,
When you said you got when you have all your logic, and then when you came and select from the orders 2024, that's what you name your CTE.
yes.
Okay, okay, okay. And did it give you an output?
No, no, because I think my code is complete. I don't.
Let me see if you want to talk through it.
Just give me 1 second.
Okay.
My machine just shut down, but it's fine.
Really?
Yeah. I think someone else joined. It's fine.
Let me see.
All right, I'm back.
Okay, I'm like, what is it? Hmm.
Can you see your code? Like for me, I think Because I was struggling to get my first code to execute. Now that I finally got it, I wasn't able to work on the CTE. So I need to like see, like, these words don't do anything for me. I need to see like the actual coding skill, like with our values.
Okay, do you want to share your screen and we can talk through yours?
Yeah, I could share my screen.
Okay, let's do that so I can see like where the gap is. Let me stop sharing. Okay. Okay. Now okay. You really could use, so did line 1 through 31 work for you? Did the it did?
Yeah.
Okay. Use that then. Get rid of 33. You use what you already tested and what already works. So get rid of that. Okay. Now get rid of your comment. I mean the comment out. Yeah, get rid of that. Okay. Yep. Now go down. Go down. Now this I already tested, it already works. So build your CTE on top of it. Now go up to your top on line, what is it, 12 or 13, 11 up there? Where did your syntax start? 11? 12. Okay. Go on top of a line. Yep. Now build out your CTE on top of it. So start your syntax with your, yep. Now your CTE name. I named mine orders in 2024. Yep. Now as now open up your parentheses and then come down at the end of your code after your yep on line 30. Yep. Now select from this CTE. Select star from your yep. Yep. Okay. First of all, I like how you're making a effort to like keep your code really clean. I like that. Yep. Now execute. See, that's why I be wanting to see because nothing was wrong. I'm gonna talk through. There you go.
I think from my understanding, it's like I didn't understand that we could just use what we already did. I was trying to think.
You always do that. I think you overthink it. You overthink it. And with you, like perfect. So with you, okay, on line 12, whatever, the top of your code, this is how structurally what you did. You went through, you did your data investigation, you're like, okay, cool. Then you came down on line 13 through 30, whatever, and you created your syntax, you tested it, it worked. Then your brain switched on, okay, now I have to do something different. When in reality, it was like you had already done 95% of the legwork on that big block of code right there. Okay. You already did all the hard work. So I think with you, it's always like, okay, now I gotta go do something else. Now I gotta go do something else. As opposed to, okay, I got this, I'm about to use this. Because your logic is really good. Like your logic is good. Um, you actually have a lot of things going on too. So on line 13 through 32, you got all of your code. Then you came down on line 28. You like, okay, I'm a left join, my customer table, my orders table. You got multiple joins in there. Then you came down on line 32 and you incorporated your logical operators. You got a lot of stuff going on. That's a complex syntax. So with you, it was like, okay, the work is done. Now I'm about to go do something else. As opposed to, okay, this work is done. I'm about to use this for that. Because it wasn't wrong. Yours is never wrong. That's what I've seen like with you. Yours is never wrong. It's always like, okay, I'm about to go do something else. But yeah, that's
Yeah, I
good.
think like the overthinking.
Yep. It's very much so overthink. Like it's very much so textbook overthinking. And then with your CTE, take it a step further. And let's say I only want an output of people who use PayPal. So when you update your logic, only update your logic from your CTE, not your full other code on line 13 through 31 or whatever it was. If let's say, and the reason being is your CTE, if I'm selecting stars from my CTE, I already had a complex logic in there. So it's already going to include all of your other code, the order dates, the join. It's going to include all of it. But let's say I want to hone it down even more and only want a certain subset of data from that. I can just use my CTE as opposed to going and recreate all that code again. But with you, it's like, it's almost like, it's almost like you talk yourself out of it in a way. Like it's almost like, okay, I have this and now I'm about to go do this. And it's like totally omitting the work that you done already done.
Yeah, that sounds right.
Yep. Cause you're like what I've seen and experienced from you. That's why I was like, let me see your code. It's never wrong. Like I can't say that I've seen your stuff and I'm like, what is this? It's always like, okay, I have this and I'm about to go and reinvent the wheel. And then in the midst of me reinventing this wheel, now I'm confusing myself. That's how yours always is. Like literally every single time. But you always have the right idea. Always. But that's very you did a good job.
Thank you.
Yep. You talk yourself out of it.
But I think that's really common, actually.
Mm-hmm.
Yeah, I think that's really common when you first start off with data because
Yep.
you think that it's so complex.
Yep.
That you feel like, okay, well, I'm finished with this, so it got to be something else. When
Yep.
really not. Like, it just,
Yep.
the complexity comes when you have a very, very large data set.
Mm-hmm.
And the data's not going to be as clean, it's going to be messy. So
Yep.
it's those, that's what complexity comes.
Yep.
I just
Yep. And I think that but and the reason that I recognize what other people do it because I do it too. And even with learning, it's like, okay, as opposed to looking at it like, okay, I'm taking what I already have and then I'm layering something else on top of what I'm already doing, which is essentially what we're doing and essentially what we do. You look at it like it's two total, completely different concepts, when in reality, it's just layering it on top of what you already know.
And that's not how I was looking at it. I wasn't looking at it as layers. I'm looking at it as two different concepts.
Yep. And it's real, it's very common. Like I always, and that's why I can call it out. Cause if I'm not, I had to get to the point where I'm like, okay, this works. Now let me go do that. Okay, that works. Now let me go do that. Like I had to start being intentional on not looking at things like it's total separate concepts, but looking at things as if like, okay, these are essentially extensions of what I'm already doing. It's very common. Very common. Very, and in the midst of looking at things separately, you confuse yourself in a way because it's like, okay, I'm looking at this as something totally different than this, when in reality they right there together. But yeah, it's common. Any other questions? Now, do y'all see the purpose of the CTE? Like I got like a QR code. I got all my logic. Now I'm gonna come and retrieve data from this portion of my code, this particular portion of my code, this CTE, as opposed to continuing to rewrite their syntax or continuing to even build upon the syntax if I have something that's extremely complicated.
Yeah, that definitely makes sense because that was a long code.
Yeah.
Code out.
Yep. Yep. And when now at this point, just start checking, like start interrupting your thought process because you, like Bree was saying, it's very common because I did it for years up until like recently where I'm like, oh, this is just, whatever it is on top of that, oh, this is just, whatever it is, because the way that like our brains work, it's just like we're gonna automatically just have things in silos. When in reality, they are the same thing, but they're just extensions of another. And like each, like for example, this what you did today is considered advanced SQL. It's considered advanced concepts, but we literally are building them on like what you already have learned thus far. And it's just an organic, like lean and extension of, okay, this is what I know. This is what I'm comfortable with doing. Now let's go and take it a step further. Let's do this. But yeah, it's very common. You definitely not by yourself. Definitely not. Definitely not. But you,
And to take it a step further, I think like because this again, this is a really clean database.
mhm,
Complexity kind of comes in here when you get those databases that have like order times down to like the hour and minutes.
second,
So
yeah.
we know how many orders are being placed before 9 a.m. on Tuesday. Then the codes don't get a little different, a little messier. So when you got a database that the columns are like 100 rows and they got like time stamps and things like that, that's when it gets a little bit complicated.
Mm-hmm. And then even when you look at it, okay, I was trying to make sure what was on my screen, but oh, y'all can't see my screen anyway. But when you look at it, like even in that, that's like still an organic lean from like what you already doing. It's almost like how,
All of it is.
huh?
I say that all of it is.
It's almost like how like a kid, like okay, so this kid they have like uh like I don't even know what they call it, the little top bikes thing, the little bitty bikes. And then it's like, okay, I'm gonna come from this little bitty bike, and now I'm gonna go to a bike with training wheels. Now I'm gonna lead a bike with training wheels, and now I'm gonna go to the bike. I'm gonna take the training wheels off the bike. Then I'm gonna take the training wheels off the bike, and now I'm gonna go and get me a bigger bike. Like ultimately, you still paddling, you still got your handlebars, like it's still set up the same, but it's just okay. We just pushing you out there just a little bit more every single time. But yep,
Yeah, for sure.
yep. But don't ever think you by yourself, because I definitely, I like I said, I just now got to the point where I was just like, oh, okay, that's just this, or that's just this on steroids, or extension of, what we already know or what we done already learned. So, yep,
That's a good logic on steroids.
it is.
I look at a database and be like, oh no, not today.
Yep. What we gonna get into today? Views is. I'm gonna explain the views too, but what we're gonna get into today with the window functions. Window functions ain't nothing but aggregate functions, but like beefed all the way up. Like that's what it is. Like I'm gonna get into it when we get into it. But yeah, it's like everything is like, okay, this is what this is. Oh, okay, now this is what this is. Oh, okay, now this is what this is. And they all just coexist and work together. Yep. Next, our next objective we covered on CTEs, and CTEs is essentially that common table expression. We have our subset of a result that we want to reference throughout our entire code. That's a CTE all day long. It ain't nothing but a sticky note. That's it. That's all. I'm gonna come down and I'm gonna pull data from that CTE. I'm gonna pull data from their CTE where this condition is met. I'm gonna pull data from their CTE where this condition is met. Or I'm gonna compare my CTE with another table, or join this CTE with another table. So that's essentially what that is. It just holds that data for whatever use you need it for. Um, Now let's get into views. So what are views? So views are fake tables. Like that's the best way I can explain it. Views function like a table. They kind of look like a table. You treat them like a table, but they're not real. And the reason that I say that is when you look at the textbook definition of what is a view is a virtual quote unquote table. And it has the columns, it has the rows, it has what a table typically has. However, the database does not actually store the data itself. It only stores the logic of that data. So what does that mean? That means when I go and I select date, select star, select whatever from my view, I'm not pulling data from an actual table. I'm pulling data from the view. And the view stores the logic that I need to get to create that view. It doesn't store the data, it stores the logic. So it's two different things. Now, what are the benefits of a view? Let's say that you are in a why was I finna say that? Position. You're in a position, and of course, data is super valuable. It's supposed to be treated in the concept of you only give certain people permissions and views to data that they literally need. Like it's always the least amount of access possible. That's the goal, supposedly, within organizations. So let's say you have a view. One of those benefits of a view is for security. Let's say you're building out reports or dashboards and you are dealing with highly sensitive data. You're dealing with, if you're in healthcare, let's say you're dealing with diagnosis, um, data that is very private. But you need to build out a dashboard because someone else consumes this data, but they might not need access to all the other data that is within that table. So when I'm building out my dashboard, I build out my dashboard to connect with that view as opposed to connect to the view. I'm sorry, not with the view, connect to that view as opposed to the actual table. So when the stakeholder comes and they refresh and they consume their dashboard, the back end of their dashboard is actually connected to a view as opposed to an actual table. Another benefit is, let's say you are in a position very similar to like the conversation we were just having a minute ago. Let's say you're in the position to where every Tuesday you get, every Monday morning you get an email from marketing and they want to know how many orders were placed over the weekend and what was certain data points of that order, and they want to know what was the average order placed on, like Bree was saying, Tuesday before 9 a.m. or whatever those specific conditions are. It becomes a regular occurrence to where it's like, oh, okay, these people need this pretty regularly. So instead of having me having to like rewrite my syntax all the time, me having to go in there and write this code every time, I can just create a view with that logic. So in the event that they need this again, I can just go and select star or select my columns from my actual view. Because when I do it from my view, it's going to recompute that logic. And there I have it. I don't have to go and rewrite that whole syntax over and over and over again. That's one of the benefits from a view. Another benefit of a view is like data integrity. I know we talk a lot about like data quality and going and look at like our data relationships, making sure that everything is good, things like that. Views allow a certain consistency within the database because let's say that there's an update. Let's say that there are things that changes the way the data is structured. Views allow for you to still have access to what you need and when you need it. Um, in the event that there are some changes within a database, I still have access to what I need. So views allow that because they position everything in a clear interface. Like I'm pulling this from here, I'm pulling that from here. I have this logic. These are my conditions. Where this condition is met, where that condition is met. And regardless of whatever y'all are changing, I'm not pulling from a full table. I'm only pulling pieces of what I need, to create that, answer that question. Um, in the syntax for a view, once again, very similar to the conversation we were just having. That syntax of a view is we have our logic here. Whatever our logic is that we're trying to capture, we have it here. But the only thing that we do different is we say create view. And we say create view, our view name. Ideally, views always start with view. View or either VW underscore. I'm typing in the chat. Okay. So views always start with view or either VW underscore view name. So create view, view name, as, and then you get into your logic. Whatever logic you want, that's what creates your view. These are also considered advanced concepts as well. So notice how we're in advanced concepts, but we're leaning into like the things that we have already learned thus far. And I'm gonna show y'all another thing as well. But any questions on that? Okay. So,
I'm sorry, I was coming off mute.
oh my bad.
So how are views saved?
That's what I'm about to talk to you about.
You're right.
No, that's a good question because it is like I started after the I ain't gonna say lecture because like who lecturing, but I started out the conversation with like views are fake tables. They look like a table, they act like a table, but they not really tables. So let's get into the architecture of views. So for this use case, let's go into our healthcare system database. Now we got our databases, we got our tables, which is what we have been using thus far. Then we come down here, right here, and we got our views. So when you create a view, you are creating data within the view, like within this folder right here, views. So this is where the logic is actually stored. We're not storing the actual tables. Tables and views are different. We got our tables right here, then we got our views right here. So this is where the logic of that view is stored. These are our tables here, and then these are our views here. So this will actually store whatever logic is that you created using these tables. It's gonna store it down here. So when you are connecting to the dashboard, when you want that data, when you want an updated data set or whatever the case is, and I want to come and retrieve data from that view, I do my view. I select star from the view. Any questions? Okay. So for this use case, let's go into our healthcare system database, and I'm gonna write your what you need to create. What okay. I'm gonna write your logic to create your use case. First things first, data investigation. Which tables houses this data? Which columns houses this data? Right click, select your top 1,000 rows, and build upon that. Um, And let's focus on building our query first. And then once we build our query, test it works. Then let's go and create our view. So let me write the use case. Mm-mm-mm. Okay. So we need our patient first name, patient last name, date of birth, gender, phone, email, medication, dosage, prescribed date, test name, test date, and result, where the patient has an abnormal test result. So that's the first things first. Data investigation, build out your syntax, test it. Okay, that's right. That's right. That's right. Or I need to do this. I need to do that. Then we're going to go and create our view with the information. Oh, let me move this out the way. I'm gonna go back to the I'm gonna go back to the join syntax so y'all can see it. And let's do a right join on the patient table because I mean a left join, my bad, I'm tripping. A left join on the patient table because I want their patient information regardless on if they have a test or not. So remember that left join pulls all the data from the left table. You know, P dot patient ID equals P2 dot patient ID and P dot patient ID. Okay. Prescription, medication, 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 mm, dosage, dosage, medication, dosage, prescribed date, prescribed date, test name. Okay, so medical test, medical test, um, dot patient ID equals P dot patient ID. Okay, so medical test, um, test name, test name, test date, test name, test date, result. Okay, result. So test name, test date, result. Where result equals normal. Okay, perfect.